So I've got a little agenda, introduction, a little bit about me, a little bit about the problem, things as they currently are, things as they might be in the future. Demonstration, which probably isn't going to go off so well since I can't present the browser so you can't see Jenkins in operation. But fortunately I have a backup email that I sent myself, which I won't be able to display either. So I've been doing software development, database design, most of that kind of stuff for 20 plus years. I've started Java when it first came out in 1.0, and that's been my main tool ever since. I've kind of migrated towards a lot of JVM tools now, including Groovy, which is pretty groovy, and Neo4j, which is part of the subject of this talk. Lead technical developer, architect at Experian Marketing Services, and yes, it is that Experian. So if you have credit problems, please don't see me. I don't have access to that database. And then I lead mentor a global team of developers in the States and currently in Costa Rica. I'm not a dedicated build engineer by profession. It's just one of the things that I do, probably like many of you. I started continuous integration 10 or so years ago. I started with cruise control, which back in its day was a pretty good tool, but if you have more than 2 or 3 projects, editing that XML by hand is a bit painstaking. I moved to Hudson after viewing a session at one of the Java 1 years by Kosuke, and migrated to Jenkins when Oracle decided they wanted Hudson. So I went with the creator. You can't go wrong there. The reason for this is basically what I explained. Is the project manager did not know what was in the build that we had just released, and the reason for that is severalfold. The developers weren't really adding excellent notes to the build. B, the notes weren't carrying over from one build to the next. So, for example, we have a build, and you probably build a project 10, 20, 30 times before it gets to the release stage. Well, each one of those builds may have some associated notes as far as issue numbers that's being taken care of in there. I like to keep notes, get branches, whatever. We have a whole list of custom properties that we like to include in the build. So the only historical reference to this that most managers have, or even developers for that matter, is in the emailed default report, unless you've set up something else. Furthermore, the data that was entered in that can't really be reused, so you have to completely rerun the project from scratch. You might enter duplicate information, etc. So hopefully by using Jenkins, Groovy, and Neo4j database, the data can be persisted. Now, the standard email notification that delivered with Jenkins is really minimalist. Failure message contains a portion of the console output, which would be error statement or a stack trace, perhaps. Success message is really nothing to look at. As you can see here, click on this link and you'll see a list of changes, which isn't very much. That's just, I think, the changes they pull off of your build tool or SCM. So employing the email ext plugin, you get better control over what can be emailed in the report. However, unmodified, this plugin is not much more useful than the default error plugin. So you'll get the name, the build number. Basically, clicking on that link will pull up the list of properties that you entered to create the build. So, for example, if build number 5, you click that link in the email, and it would pop up something where you can view the parameters, such as the Git branch used to build, some notes if there are any, and all of the other user-entered properties. Now, if you have multiple builds, like I was talking about earlier, if you've got 10, 20, 30 builds down the line, it's really difficult, if not, you don't want to do this. You don't want to have to click open every single link, go back to the build, see what the parameters that were entered were. Quite frankly, they're not going to do it. And so they're going to say, hey, what did we just build? Hopefully. So as the example here, you run 3 builds and include notes for each build. So therefore, you're going to get 3 separate emails. You would need to click on the link for each one to pop up an individual build report, and that's pretty much of a hassle too. So, and then if the build administrator discards old builds, you're not even going that far. But I believe there is a better way to do this. So wouldn't it be nice to receive an email that has this formatted content on it instead of the generic click on this link to see what parameters were entered? You get the email that will give you all of the information that you choose to display to your user and or project managers. Now, in this example, you have the release tag, which would be used further on down the line to, say, move it from staging to production, et cetera. The build number, the Git branch used to build this, the version number there, which is pulled from Artifactory itself. The build notes, which accrue for every build, and the URL of the deployed application. So actually clicking on that link will bring up the application, whatever it is. In this case, it happens to be a deployed WAR file. So you would see that. And it looks just as good on your mobile device. So if you're getting this, it would be nicely formatted since it's HTML, CSS. And on this example, you can see I have an extra build note. Also, wouldn't it be nice to save, review, reconstruct, and print reports from any and all of the builds that you've currently done? And this spans multiple projects, as you can see, via this spiffy little interface. This is actually in production at our shop. So basically clicking on one of those build tags, which is actually its own Git branch, would bring up all of the information used to construct that build and build it. So that's really what we're trying to accomplish here, is to send them a nice little email that looks like this. Further, in our shop, we also have a list of the bug issues. So it would be either listed by number and description. So I don't have that in here because it's just a demo, but it would have a list of 10, 15 bug issues in there, JIRA issue numbers or whatever your issue tracking system is. And this is how it's done. You can see what I sit around watching late night when I'm coding this stuff. Just watch it, and I know when all the, I've seen them all multiple times, I know when all the jokes are, so I look up from my screen, laugh a little bit, and go back to coding. So for this Jenkins job, the main components are Git, Groovy, Gradle, Artifactory, and their associated Jenkins plugins. The database I'm using here is Neo4j, and I'm also making use of these other associated Jenkins plugins. Now, why Neo4j? Why did I choose Neo4j? When I first started this, I was using a MySQL database. Adding projects with different build requirements, you know, as time goes on, people go, hey, we like that, can you put it into our project too? So I did, but some of their projects, they don't deliver WAR files. You know, some are jar files, some are zip files, some are flex SWC type files, Ruby things, gems, that's what it is. So there's all different kinds of requirements, and I found that the original structure of the database was getting very sparse. You know, I would need an entire column just for a particular project to hold a particular point of data, and it started getting sloppy. I didn't like the feel of it. So I started looking around at NoSQL options. And since I'm familiar with the JVM, and I'd heard about Neo4j, and it's not a new tool, it's been around for quite a long time, I gave it a shot, and it seems to fill the need that I was trying to get rid of that columnar database style. So I'm not going to give a tutorial on Neo4j, that's not the scope of this, but just a brief overview. Open source, NoSQL, implemented Job and Scala. The fundamental units that form a graph are nodes and relationships. That's really all there are. A node can contain any kind of information, and it can be linked to any other node via a relationship. So that's kind of like a table giant, I would think. Nodes are often used to represent entities, and I will show you that on the next slide. And relationships connect the nodes. So the nodes, and this is just the basic, these aren't all the nodes that I'm using, but these are the basic ones used in the demo that I can't show, is a build node. That's the main node here. That the Jenkins, when you push the Jenkins build button, it will compile all the information, it will go out and build everything, and then it will create in the database a build node. It will make use of the SubProject node, which contains all the information this particular project will need to build. And then the user server, these are ancillary nodes. So the properties that I'm including on my SubProject node, that is a main node, are the SubProject name, the title, the artifact ID, that's how it will be located in Artifactory, the extension, war, zip, gem, whatever it is, the directory where it can be found in Jenkins, because different build tools put things in different locations. So Gradle will put them in lib, Maven will put them in the topmost build directory, Ant, which we also use Ant to build our flex files, puts them somewhere else. So this is where the Groovy script will locate the artifact to deploy it to your binary repository. The Git repo name, so it can download it, check it out, build tasks. Now, this is specific right now to the Gradle build, but if I had a SubProject node for a Maven build, I probably wouldn't even have a property named build tasks. It would be profiles or whatever, whatever it is there. And these are just key value pairs. The query language that Node4j uses is CYPHER. It's SQL-like, yet not SQL-like. So there's some crossover, like where, order by. You would all know what to do with those. Match is very akin to a select statement. And you can return, well, you can return pretty much whatever you want. So here is an example create subproject. This is how I'm creating a subproject node. This would be in the gray box there, that is the CYPHER statement that will do, it will create a subproject node and it will link it to the main project, which I'm calling JUC. So we have main projects with multiple subprojects under them, and we like to group them. So the first one just matches and gets the node where JUC is. Then you create the subprojects with all the properties that I just explained. And that last bottom line creates the relationship between the main project and the subproject. Now, Neo4j, it provides, out of the box, it provides an interface on port 7474, on whichever server, that can be changed, they can all be changed, to access a REST-based query submission. So you can query the database via REST statements, which I find to be very convenient. If I could pop up the browser, I would show you an example of this. However, just know that when I enter in you can see in the top, the match subproject, that is the CYPHER query, and it does return these two. It returns a project and a subproject that we had just created in the previous slide. Now you can also view the data behind this. There is a button on the web page itself, which will allow you to look at the underlying data. So this is what we just inserted. You can either view it as nodes, as in the picture before, or you can view it as data. I do both. Now, if we run the build, this is what the build node looks like. So it's got all of those projects that I showed you. So the main build node, which is 71, in the middle, you can see all of the relationships going out to all of the other nodes, and that note would be the note that the user note and or note. So for every note that the user entered, there'd be one of those nodes. It's very simple. So let's just say I run a second build on that same project. The graph would look like this. This is pretty much getting to the end of my Neo4j tutorial, but you can see the common, the builds themselves are different, but the common elements would be localhost, which is the server I'm running on, the username, and the project, SubProject. And that statement at the top, match the build with empty brackets. The empty brackets means basically include all relationships. And N as your node, you're not specifying a type, so you're including all nodes. So you're getting all nodes for all builds. Now, how would we do this in Groovy? And that's really what we're here to do. You create the CYPHER statement just as a regular Groovy string. You substitute your variables that would be replaced from the other information. The user ID is probably coming from Jenkins. SubProject name also. You have to know what you're running. So then you're going to go out and you're going to query. This query will return, and it's going to create the new build. It will create the new build node. So this is what you would enter in your Groovy code. To execute that statement, just create a regular Groovy REST client, and as you can see, it's just localhost 7474 DB data cipher. That's the default. Those can all be changed. Set it up to accept or send JSON, and then just submit your Groovy string, and it will return a JSON formatted big long string of objects that you will need to parse at the end, but it can be done. Now, I guess next steps on this would be probably to try to integrate Spring data to handle some of those mundane tasks, but that's another lecture. Now let's see how this all works. So we will enable the parameterized build in Jenkins. In this particular instance, I just got to get branch and notes, and this is what the user will enter. I'm defaulting to master for this project. Notes can remain empty or they can enter in some notes. I'm going to check out the Git repositories and branches to build. So whatever they entered in the Git branch parameter will be replaced here. So once it checks out the project, it will also check out that particular branch. And I find this useful in testing. I'm also checking out to a subdirectory, which is to be named, I usually just name it whatever the project is going to be. And the reason I check it out to a subdirectory is because all of the Groovy scripts and the code that is underlying this is also maintained in a Git repository. So I don't want to confuse the two. I will check out also the Groovy scripts to yet a separate subdirectory, all under Jenkins. I'm just going to define a couple of environment variables just for ease of use. The properties file, which is the file that's going to be passed back and forth between Jenkins and the Groovy scripts so that all of the properties remain in sync. And basically the location of my Groovy scripts. Inject some passwords. These are to access the database or anything else you may need, perhaps SSH, whatever passwords you need. Some can be global. Now, in the build steps themselves, I am taking the information that the user entered and some other information. Here I've got a hard-coded application. That's what's going to find the SubProject node. And I am saving this out to a properties file. I'm using Bash to do this because I'm running this on Linux. You can also do this using Groovy. It's a little more cumbersome. I think Bash still has its uses in this day and age. In fact, this project, before it was using Groovy, was using Bash, and that was a bit much to maintain. So once I discovered the Jenkins native Groovy implementation, that's all it took to change that over. So this is just going to write the properties that the user entered and other things that the scripts may need to a properties file that will then be read in by the Groovy script that we're going to execute. And here it is a little bit bigger if you couldn't see it before. That said statement is basically just taking the notes, because since there's one node on each line, I am just concatenating the notes with a tilde and removing the new line so that it looks and parses better in a properties file. Now I'm going to export the job runtime parameters, and this is a Jenkins function. It will export these types of properties. There's a whole list of them, and I don't use many of them, but some of these I do use to complete the report. It by default exports it to hudsonbuild.properties file in the workspace root directory. So after doing all of this, this is what the workspace will look like before we really start doing any processing. There's the JUC Groovy. Those are the Groovy scripts, the Hello World, which is the project we're going to build, and the two properties files, the Jenkins and the one that I created with Bash. So now we're ready to execute one of the Groovy scripts. I use one script. You could use two. You can do it however you want. I call it twice. First is there's a pre-build section. The pre-build executed prior to running the Gradle build or your Maven build or your Ant build. Post-build, by default, runs after that if it's successful. The pre-build script will really just load properties from the database. So it loads the properties file we created, juc.properties, gets the project name, the workspace directory, other things. It will then query the database, the Neo4j database for that project, and retrieve all of the associated information with it. It'll get the server we're going to deploy to, the project name, the Git repository, and all that. And here I've manually checked out the Git repository. But in production, since I use these scripts for just about every project we run, because they're fairly generic, all of the information kept in the database, I keep also the Git repository in there, so when I check it out in the pre-build, I will then just check out the Git repository that's just loaded there. And then it appends these values that it finds in the database as new properties to that same JUC properties file. So after the pre-build, that same properties file that had maybe 5 lines in it now has all of the information that was contained in the database as well. It's got the server, the port, I mean, anything really. This is some of the information that I keep, but you can put whatever you want in there. So once the pre-build is done, you need to inject these back into Jenkins so that Jenkins knows of the existence of all of these values from the database. There's an inject environment variables plugin that works very well for this. You just give it the name of your properties file, and it just imports them back. And now these are ready to be used in further areas here, such as when we run the Gradle build or the Maven build. As you can see, I'm using those properties that we just retrieved from the database to set up the Gradle build, which would be the build tasks, which they can vary from job to job. The project directory, in case this is a nested project structure, that also works. So those are some of the ones. So then we execute the Gradle build, and we assume that it's going to run just fine and complete successfully. Now, after some of these steps, and I don't think I've included that slide, but I do check a property in the properties file called error message. And if there was an error message, then I will stop the Jenkins build, because it doesn't natively know that there was a problem in the Groovy script. You can throw an exception, but I prefer to run the error message and then complete processing down the line. Because if you throw the exception, your report at the end won't run. It's a better way to go. Then we execute the post-build Groovy script. It's the same script, just a different switch, part of the switch statement. As you can see in the script parameters, the second parameter is post-build, whereas the first one was pre-build, and so the script knows that it executes the post-build code. This one will again load the properties file. It'll get the artifact information from the Gradle.build file itself. It will create a unique tag name based on the project name, the version, and the build number. It'll aggregate notes from the previous builds. That's one of the problems we're trying to solve here. So it'll go back into the database because it knows that this project with this version has prior notes associated with it. Create some HTML elements to use in the report, and that's really just creating list items. You really can't iterate through code in your email text, so I just create the lists in Groovy and send them back. It will then create and push the new branch to Git using the new tag name, so that'll be the new branch, which can be used in further processing. And it will append all of these new properties, tag name, versions, etc., back to the properties file, which we will again read back into Jenkins so it can use it for the final run here. Post-build actions. So once this is all done, the artifacts have been deployed to Artifactory or your binary repository of choice. The Groovy scripts are done. We still have some things to do. Now, if it's a web app, we also tend to deploy it to Tomcat. It's an integration server, staging server, wherever it's going. And that information is also kept in the database. And then finally, we send the email. So to deploy to the container, for this example, I'm using just to deploy this particular plugin. In house, though, I don't use this anymore because I had problems early on with this not properly parsing out the environment variables that you need to pass into it. For example, the URL can change, the context path will change based on the project. So I now do this in a production instance, just also in a Groovy. Since we're running on Linux, it's just easy to execute a curl statement to directly access the Tomcat manager and undeploy, deploy, test. It's pretty simple. As you can see from this just snippet of code, this really does it all. So finally, we're to the email. The X plugin can use the environment variables. Excuse me. So you can set this up. I use the HTML content type. You can include CSS or any of the HTML that you want in there. The dynamic portions of the email populated as properties in the properties file generated by the etc. So this is what the basic one would look like. You see the content type is HTML. The default, the subject, these env var equal statements are the plugin's way of importing the environment variables, which are the properties in the properties file. So many of these come from the database. Some of them, like the version, build number, are generated per build. And you can see it's just, the content is just CSS and some HTML, along with your variable statements. If the build is successful, now, also you can configure it so that was just the default. That this one here will run for every report, whether there's a success or there's a failure. This just gives the build information. Now, if the build's successful, I will add additional sub-information. As you can see, the user notes will be included here. App links, which is the link to the deployed Tomcat application. And they can see under the user notes HTML, I've just got it surrounded with an unordered list tag, and that is where in the Groovy I just create list items and concatenate them from the user entered notes. The demonstration, unfortunately, is not going to happen because I can't pop open my browser to display it for some reason. They say it's not set up for that. There must be a way. I don't know how to do it. What the demonstration would have involved was running the Jenkins project, adding some notes, showing you that the build was inserted into Neo4j. Then I would have changed the source code a little bit to display a different message on my web app. Run the build again with a different note. You would have seen that the email that should have been sent to me had both notes on there. Clicking on the link would have showed you the updated version. So, unfortunately, I don't know how to make that happen. Thank you very much.